Okay. Okay. Am I audible?
Yes, sir.
Okay. So we left here that this is the expression I have written. This expression I have
Yes, sir.
written. Now I want like complete expression for V out y I in, because I want to see all the poles and zeros in this expression of transfer function. So this is the one method. One thing is the use mathematics here. Put a of s equal to a naught one. That is the one thing. Other thing I want, you
Yes, sir.
told something about the loop gain. Loop gain. What is the loop gain in general?
The gain of an amplifier with the loops.
Okay. So like, can you calculate this expression? Can you compute the what it be? Like I should again draw this amplifier. It has the transfer function a of s or gain as a of s. This is RF, V naught, C in, I in. So write loop gain for this circuit, LG of S.
So in order to find the loop gain, I just nullify the input and break
Okay,
the loop at this point
great.
here, here, and apply V test on nothing but loop gain is nothing but minus VF by V test.
Okay.
If you apply
So
V
can you
test
write?
here,
So okay, I will draw the diagram for you that you want to see. Okay, wait 1 minute. I will draw the diagram. And I think you want to say like this. Let this is my amplifier having minus plus. You want to break it here.
yes,
RF. This is my V naught. This is my A of S. This is our C in. And input you want to make it open. That's it you told, now.
yes,
Here you want to apply, or here you want to sense the V feedback, and here you want to apply V test. That's it, huh?
yes, sir.
Okay. So now calculate the loop gain.
To apply V test here, then V not equal to minus A, nothing but it's gain into VT. If you see, now we can apply voltage division here to find the VF. Uh, VF equal to minus minus gain of the minus A VT into this resistance 1 by S C in RF plus 1 by S C in. But
So what is the expression?
that's right. So I think VF equal to minus AVT by 1 plus RF into SC in minus AVT by 1 plus RF into SC in. So this is the VF.
Okay.
We want minus VF by V test. So
Okay.
the loop gain equal to A by 1 plus RF into SC.
So this is the complete
Yes.
mathematics you followed and you got the answer. That's fine. So, like, can you tell me what are the exact
And
poles and zeros you are seeing in the loop gain?
I think one pole is located at infinity, sir.
One pole is at infinity. Where it is at infinity? Where the s in the denominator? Oh, sorry. How you are saying that it is like at infinity?
I think this is a second order circuit now.
So where is the other pole?
Nothing. One
Nothing.
pole
What
is at
about the A?
minus A. You want
What
A,
about
sir?
the A you are using here?
Yeah, A of S here.
Then what is the A of S?
A of S. A of S. You wrote the equation. I just forgot there.
Okay, I will write again. A of S is first order system A naught 1 y S y omega P1. This P1 is 3D, oh, sorry, like it's the dominant pole of amplifier. It's a first order system only. So this is the expression. So what are
Yes.
the pole and zeros now?
One pole is at minus 1 by RF into CN.
Hmm.
I think
Okay. Other pole?
uh,
Where the other pole?
infinity or something else.
Why infinity? Why are you not looking in this A of S? A of S has pole or not?
Yes, sir.
Where?
Omega P1.
At omega P1. Where the pole in this? Where the pole in this? In this expression where I like closed in the bracket, where is the pole in this? What is the complete expression for loop gain now? You simply put now. If you are like you're writing the loop gain, what here it is directly put E of S times you are writing something 1 plus RF seen S. And if we are writing complete A of S here, omega P1, other term is multiplied with 1 plus RF C in S. So one pole is like P1, I should say, is defined at omega P1, or I should say, okay, that's fine. And P2 is coming at
Minus 1 by
1
RF into
upon
C.
1. Minus is fine for S. I am talking about the frequencies. So
Okay.
RF seen. Okay. So the condition I am giving that amplifier's pole is dominant. It is much lesser than this 1 upon RF seen. This is the condition that we are keeping to design the amplifier such that it is like that. So what is the Bode plot or for this particular complete expression? You got now transfer function or loop gain you got. So what the Bode plot for the loop gain? with the condition holding omega p1 much lesser than the RF seen, 1 upon RF seen.
Yes, sir. So you want Bode plot like right?
Yes, yes, yes. For this loop gain.
Only for loop gain. So it has having the so it has two poles, right?
Okay.
So let's encounter these poles and having the gain of A of S.
What is the gain?
Gain A of S, A naught.
A naught is the gain now. A of S has some frequency term. Now A naught is the DC gain. Where you will define
A
your
naught, A naught.
body plot is starting at the A naught.
If A naught value is greater than 1, it's positive.
Yes, yes. Of course, it is greater than 1. 10 I have given, but it is higher usually.
Yes, sir.
Hmm.
Yes, sir. So we have to make constant until the first the omega p1 encountered and 20 dB per decay here. Sorry. When this was encountered, another 20 minus another minus 20, so total minus 40.
Okay.
Here minus 20 dB per decay. Here minus 40 dB per decay.
So, are you aware about like UGB and phase margin? So, where the UGB for the
And
system?
unity gain band. Like,
Hmm.
I think here, sir, I don't say like that, but it is the frequency at which the magnitude becomes one.
Hmm.
Like by multiplying gain and bandwidth, we can get the UGB. Right?
By multiplying gain and bandwidth. So, how will you
Yes, sir.
see here the UGB?
Sir, here the A
Like
naught is the gain.
for which system it is valid? You are saying that it is gain times bandwidth,
uh, Low pass filter, sir.
low pass filter. But what is the condition? The condition is that the system is first order. When there is only one pole, there is DC gain. The concept you are telling now that is valid for the system.
Yes, sir.
That is valid for the system. There is some DC gain. There is one pole only, and it is cutting at this frequency that is called FUGB. FU sometimes called UGB. Okay. So when there is only one pole system, that is a FP1. For the amplifier, I have given this transfer function only. For the amplifier, I have given this thing only. In that case, if it's a first order system, there is a minus 20 dB per decade slope around the point where it is crossing the 0 dB gain. This is a gain at 0 dB. This is a gain in dB, some value. So when the gain is crossing the 0 dB line or unity gain, that called the unity frequency,
Gain band.
unity gain frequency or unity gain bandwidth something. Okay, that is the point.
Yes, sir.
But directly saying this thing that UGB is equal to gain times
Band. Number.
FP1, this is holding only for the first order system. If there are some pole in between, then what will you see? If their FP2 was coming here, then it was actually going down. So it was now ideally it is cutting here. So directly multiplying this with this is not going to give you this point.
Yes.
It will give you this point, which is actual UGB.
So in order to substitute the value in transfer function to know this thing. Or
Yes. So because of second pole, my slope is now decayed, or like
yes,
it's
sir.
from
I
minus 20 it is
understood,
going
sir.
to minus 40. So it is cutting earlier. It is
Yes,
was
sir.
supposed to cut somewhere. Now it is cutting earlier. So that was the UGB, actual UGB. This was the only for amplifier. This was the UGB for amplifier, also called open loop UGB. I can say open loop UGB. Now you are putting the negative feedback. Due to the negative feedback, this pole 2 is coming. due to the feedback circuit, pole 2 is coming and my slope is now increasing.
Yeah.
It is cutting somewhere else. So this UGB is called closed loop UGB. With the loop gain we calculate, that is called closed loop UGB. So when there was
Okay,
no
sir.
feedback, only amplifier was there, this was my open loop UGB, which was directly gain times FP1 over the 3D frequency.
Okay, sir.
Okay, so this thing you keep in mind. These things keep in mind. And what is the open loop UGB? If you are putting some negative feedback, how this feedback is influencing. If some extra pole is coming due to the feedback network, then loop gain will encounter some other pole due to which actual slope of the amplifiers means body plot will go down. Sorry,
Decreases.
go increase. So it will cut at some other place. That is actually UGB for a system. Okay. So I think this is enough
That is a
discussion
closed
for
loop
this.
UGB.
That's the closed loop UGB. You can mention this thing in your interview
Yes,
also.
sir. Okay, sir.
Okay. So this is a discussion for like now I will change a little because a lot of things we have discussed on frequency analysis.
Hello,
Now
Anuj.
fourth question. Hello.
Yeah, before proceeding fourth question, I have some two or three questions to ask. Can I ask?
Yes, yes, you can ask. Sure.
So my question is from network theory. So it's a
Hmm.
simple definition. Uh,
Okay, you can
Wait
ask. You
one.
can ask.
Yeah. Wait. So do you aware of the three terminology, like let's say ground, earthing, neutral? Multiple times we will use these terms in electrical circuits, right? In different
But
applications.
I have only know about ground because I am not from the electrical background.
No. These are not related to any electrical background, but these are the
Okay,
fundamental things, right? So whatever, these are just a terminology, not a concepts.
okay. I
So,
know about
so
ground only. Yes.
earthing, ground, and neutral point. So my question is, what is the difference between these three, and what exactly making the difference for naming convention? So some quantity is there that is making the property of the not property. Let's say uh, that exactly some reason is there. For that one, they have mentioned the different names. So in commonly we will use the ground concept, right? We
Yes.
Please highlight. Yeah, we will use ground, right? This one in circuits actually, some circuit. So and similarly, we are having neutral point and earthing. So, do you aware of three-phase system, three-phase balanced system?
No.
You don't know three-phase?
No.
Okay.
I think these are comes in electrical branches like triple A because I am from EC.
So, whatever,
They
but
are now out of scope from my syllabus or from my bench.
okay. Fine, then try to think about that one. But this is not anything related to branch actually. These are the fundamental building blocks. Just a circuitry thing only. This is not related to any concept because
Okay, I think.
grounding, earthing has basic definitions of the circuits
Okay.
where we need to use
Okay. In
something.
circuit, let's know about ground. In circuit,
Yeah.
generally
So
ground is a
okay, you don't know about any earthing and neutral point definition, maybe.
yeah. Yes.
Yeah. Okay, it's fine. Then I think you can try to figure out the solution for that one. So and one more question I have was, do you know LC circuit? Any oscillations? LC oscillations? Have you
Uh,
heard about? Huh?
yes.
Yeah, like the circuit will look like this one. I think so. So this one we will call LC circuit. So we are having, see, LC oscillations we will call, right. These are fundamental second
Yes,
order
sir.
circuit, right. So when we connect the L
Yes.
and C in the parallel, so for generating oscillations, the frequency of the oscillation is decided by 1 by root
Root
omega,
LC.
yeah, root LC. Correct. This is the frequency. So means let's say
Yes.
if you take voltage or current waveform, let's say I will take voltage waveform. The voltage waveform will come like this, right? Somewhere, something like this. Huh?
Yes,
This is
yes.
called oscillation only, right? So
Yes.
whatever, don't care about DC. Let it be. This look similar to oscillations, right? Hmm.
Yes.
So my question is, why these oscillations are occurring? Why this is occurring?
Because if you
Hmm.
want any oscillations, we not 0 or 360 degrees phase shift, right?
Yeah, that is mathematical term. But circuit, let's say I am inside the capacitor.
Because
That how the
like
capacitor will
initial,
get to know? See, listen. First,
because
listen. Wait. Let's say I am sitting inside the capacitor. How you make sure that I am at 90 degree, I am at 180 degree? Mathematics and all developed by humans, not by circuits, right? So circuit, how it is getting to know? Okay, I am at 180. I need to do like this. It is not the case, right? But still, in physical, it is happening. Oscillations are coming. I am asking why the oscillations are coming. Means what is the reason for oscillations? Let's say, let us assume no internal resistance. Initially, I have charged the cap or inductor, whatever. You can take anything. So I have charged capacitor, whatever, or inductor, some up to some value, let it be. So when we connect to parallel network, so it will it will went to oscillations. Then the oscillations will occur, right? Normal, because any feed forward source is not there here. So it is happening like the if we take the voltage or current whatever, so it will be going under oscillations. So I am asking why these oscillations are coming, means what is the reason for getting the oscillations? Means let's say these are very
there is an
pure sine wave, right? Pure sine wave, no energy is dissipating, because I am saying these are energy storage elements, no resistance are there. But so how these oscillations are occurring? What is the main reason for occurring oscillations?
because there is a presence of noise in the DC source.
DC.
We are applying DC, right? There is a noise presence in the DC. So due to the phase shift, some oscillations
Okay,
are coming.
okay. Let's say I will not inject any noise. Then also it will occur or not?
No, no.
I don't.
Irrespective, without noise, there is no oscillations are coming.
Without noise, there is no oscillation.
Yes, yes.
How? What is noise mean from your perspective? What exactly noise means? You are saying DC.
Let's say,
Ah,
yes,
okay.
in DC, right, it is
Yeah.
a pure DC. For example,
Ah,
there is a noise like
yeah. Okay, okay,
something.
okay. Means I am saying I have charged the capacitor to some voltage with DC voltage. I am
Yes,
saying ideal case. I mentioned earlier ideal. In ideal case only, I got the oscillations. In ideal case, there is no noise, zero. Still, I am getting oscillations. How I am able to achieve the oscillations? Let's say I am not charging the capacitor. I will charge the inductor with some current. Then still, I will get oscillations, right? Then where the noise is coming?
yes.
I am asking whatever, irrespective of noise.
Okay. Initially, the capacitor was charged now.
Yes.
So there is a voltage drop across the inductor that causes the current to flow in this direction.
Yes. Yes.
So capacitor was discharging now.
Yes.
If current is flowing this direction, the capacitor discharging
Yes. Yes. Correct.
in opposite direction. Due
Okay.
to this
Okay. Okay.
opposite direction, current is
Hmm.
flowing in this direction.
Okay.
Due to this, I think this is oscillation only now.
Flowing of current will matter. Let's say I am taking the voltage waveform, right? I am not taking current waveform. Okay, if I take anything, current or voltage doesn't matter, right?
No voltage, yes.
Let's say I will take current, I will take voltage, but oscillation is occurring, right? It's a mathematical
Yes,
graphical representation only. So because of current, you are saying oscillation is coming.
yes. Yeah, initial there is some current or some initial voltage drop across these two affected
Okay.
energy
Hmm.
storing elements.
Okay.
The
Okay.
oscillations
Okay.
will occur due to the reason I just said.
So let's say if I charge the inductor, then current will not flow immediately, right? Then how the oscillations will come? Inductor is
Because
a current stiff element.
yes, yes.
Then voltage will develop, right? So here you were
Now
saying initially because of current, you were saying now because of voltage. it is getting. How your statement is perfect. I am saying you are saying whatever you said was correct. I agree, but your statement need to valid for all the universal cases, right? So in one case, initial point is current. One case, initial point is voltage. How you are justifying that only initial point current will make the oscillations? Then what about voltage then? Because you mentioned only current in your statement. That's what I am asking. Let's say if I charge only inductor, then voltage will develop immediately. So in that case, what will happen?
Voltage will not develop immediately, but linearly it will rise.
Yeah. Now the reason for oscillations are here voltage. Earlier, because of current. Now reason is voltage. Okay, whatever it will develop late or slow, it is fine. But you are saying voltage will develop, then it will occur oscillations, right? You are saying 50% of the correct answer, but think some more. What causing the voltage development and what causing the current development? Simply, I can say one thing. You can just analyze the circuit by 2 to 3 cycles. What exactly happening in the circuit? Just analyze 2 to 3 cycles. You get to know. Initially, I have charged the capacitor. I connected. Then analyze for 3 cycles or 2 cycles. Then you get to know what is happening in the circuit. You only need to tell me. In first cycle, second cycle, third cycle, how the current is flowing, how the voltage is flowing. Tell me.
Okay. Initially, the voltage has some voltage, right? The capacitor
Huh.
has some voltage, right?
Mm-hmm.
Okay. Whatever the voltage is directly applied across the inductor.
Mm-hmm. Okay.
Okay. Due to the flux linkage, it assume the 5 volts.
Okay. Mm.
Due to the flux linkage, some amount of current is flowing. Not assume it is at equal to 0.1 ampere current is flowing.
Oh, let it be. Numbers are okay. Numbers are fine. Up to some
Okay.
value.
Something
Of,
up to
hmm.
some value.
Mm-hmm.
But at this point, like 5 volts, 0.1 ampere for my
Huh.
simplicity
Okay.
goes.
Yes. Okay. Then.
What is the 0.1 ampere current is flowing in this direction now?
Huh.
You 0.1 ampere current is flowing in opposite direction to the capacitor.
Okay.
So
Opposite.
initially we assume
Okay.
5
Yes.
volts
Yes.
in this direction.
Okay. Correct.
So
Correct. Okay. Huh. Hmm.
due to this reverse current, the voltage is decreased.
Huh.
Like let's draw the graph. So initially 5 volts.
Hmm.
So it was decreasing
Hmm.
uh, until there is a maximum amount of current
Hmm.
is flowing through the inductor.
Hmm.
So at that point, there is a negative voltage developed across the nothing but. If you consider this is the voltage,
Hmm.
negative 5 volts is developed across the
Hmm.
capacitor.
Okay. After.
Uh, if you see there is a voltage drop in this direction, plus 5
Hmm.
volts in this direction, plus
Hmm.
minus.
Okay.
Current flowing in this direction.
Okay.
The next point, the current flowing in this direction whenever the
Hmm.
polarity changes.
Yes.
So likewise, the oscillations will occur.
Because of direction change, you are saying.
Yes,
Hmm? Something is
yes.
really happening here. Okay, I will give one clue. You know, pendulum?
Yeah, yes.
Pendulum. Yeah, this is pendulum, right? Let's say I have released the pendulum from here. Hmm? It will come to here. So, ideal case, I'm saying no friction, only gravity is there, no air friction is there, ideal, no losses. So, if I release the pendulum from this point, so it will, what is the mechanism we call this one? This one. Hmm? Can you call this one as oscillation, right?
Yes, oscillate.
So, can you tell me what exactly at first point and what exactly at second point and what exactly is third point? In terms of energy, can you able to say? I am giving one more clue in
No,
terms of energy. So what exactly at the first point and what exactly at the second point, what exactly at the third point? What is happening to that system in terms of energy?
At second point, there is a energy was zero, like a stable state, right?
If energy is zero, how it is able to approach third position? If energy
So
is
it's
zero,
second position,
uh,
maximum energy is there.
then what about first one?
First position, it's going this direction is losing energy.
Losing means somewhere it is going. Where it is going? Conservation of energy, we need to. I said ideal, no losses are there. Energy is in the system only. Somewhere it is going. Think in terms of energy, different forms. What is exactly happening at the first one? Energy. Can you write the energy equation? Let's say this is my ground reference. Let's say this is my ground reference. Tell at first point what is happening in terms of energy.
Point
Means the
the
system is having
energy
zero
is
energy.
yes.
With the zero energy, how it is getting motion?
Zero mean nothing but negative energy.
Okay, what is that energy?
Minus Vx.
V?
Vx.
What is Vx?
Well, I don't know about pendulum, right?
Huh?
I don't know much about this energy something. I
Oh,
forgot.
energy. You don't know about energies. These are the very fundamental
Yes,
concepts from intermediate, right? Okay, I will only
but I
tell
am
the
not
problem.
intermediate.
Yeah, whatever. If you are not intermediate, then energy at least it need to be there, right? Without those concepts, how you got this till BTech? I don't think so. Which college you studied then? So
Actually,
first
I'm from
point.
diploma background.
In diploma,
They
definitely it
they
will be
don't
there.
teach
Definitely it will be there. Energy, conservation of energy, must and should. Everywhere it will be there, right? So, how you are saying,
like
if you
they
say these
only
type
ended
of
at
things,
basic level.
if you say these type of things in interview, right, what will happen? Definitely. They will- So, just wait and listen. Why are you hurry? Be calm and patient, mate. Huh? Uh. This is a this is from simple mechanics. You can say in first position, the position pendulum is at rest position. It means it is having potential energy. Potential energy. What is the definition of potential energy? When the object is at rest, it is having some energy. That is called potential energy. In the second point, the pendulum is at maximum velocity. It is in motion. It means it is having kinetic energy. So at first position, it is having some potential energy. All potential energy is converted to kinetic energy in second position. Again, that kinetic energy is converted to third position into potential energy. So it is going to third position. This is causing the oscillation of the pendulum. So now you got to know what exactly is causing the oscillations in the system, not about pendulum, in the system. Let's say it take electrical system, mechanical system, whatever. Something is transforming between the system. System is same, but some energy forms are changing. Now you understood, right?
Yes.
So potential energy, energies are two types: static energy, dynamic energy. Here, potential energy is the static energy, kinetic energy is the dynamic energy. Ultimate final conclusion is static is converted to dynamic is converted to static. It is in a reverse equation kind of. It's a
Yes.
cyclic process. So that's why PE KE PE KE. It is in the loop. The transfer of energy is causing the oscillations in the system. So now I have given the lead. So now tell me in the electrical system like LC, which is causing, like which type of energies are causing the oscillations, and which one is static, which one is
Oh,
dynamic. You need to say.
Voltage and current.
Voltage and current are not energies.
Like potential energy.
Potential energy is in mechanical energy, not electrical
Potential
energy.
difference. Potential difference.
Again, that is not energy. Okay, potential difference correct. That potential difference, what it is creating? What is creating potential difference?
Is the movement of electrons. Like
Yeah, then what is that movement of electrons we call?
current.
So, what type of energy is storing when the current is there?
Magnetic energy. Magnetic
Yes,
field.
magnetic energy, correct. Magnetic energy is like magnetic field. Okay, magnetic field. What type of energy that is? Static or dynamic?
Static.
Magnetic field energy is a static energy. How? So
Because
then
it
what
is
about
stable, right?
voltage? Like here you said current magnetic field is there. In capacitor, which type of energy is there?
Electric field. Like
Electric field. Okay, then electric field is which energy? Static or dynamic?
dynamic, right?
Dynamic. Electric field is dynamic.
Static.
Static. How? You are just saying one or two option. Justify your answer. Think.
One or two option,
I
huh?
think static.
Just think before saying anything. Just think why that one is correct. We are giving lot of time for that one, right? If you are saying static, what making that as static?
I think I
Yes.
don't know about the static. Then I only listening now only.
Okay, fine. Like these, fine
I
then.
think the magnetic field
I
is
think
converted into electric field.
he is missing some energy part. You can cover if it's possible for today. I think maybe in capacitive and inductive circuit you can see charging and discharging is fine for the
Yes.
energy storing elements. As of now for the analog or interview, but at least you should know that how the capacitor and the inductor are exchanging the energy between. You simply analyze the LC circuits, the tuning circuit,
Yeah.
tuning box. I think.
Yeah, simply capacitor energy means electric field energy. No electrons will move, right? When you say
Yes,
capacitor
yes,
is
yes.
fully energized, so whenever the field is created, that field will not make movement of electrons, right? So field is there, only field is there. So that field is a static energy because no motion of electrons are there. So once the current is flowing through the inductor, that is magnetic field, it is generating. Motion of electrons will create magnetic field. So whenever the electrons are in motion, that is creating as a dynamic energy. So like that, dynamic is changing to static, static is changing to dynamic in forms of electrical to magnetic, magnetic to electrical field. Like that, the oscillations are occurring in the LC. This is the main root cause of the oscillation for any system. That's why I said only fundamental thing about the
I said like
static and
magnetic
dynamic.
field converted into
Yeah, but you
in
need to
terms of
specify
energy.
static or dynamic.